Can you hear me now? I think that's a yes. So, ahoy mateys, right? Let me tell you about the MS Contentful. MS Contentful is shipping the blue oceans of content infrastructure and content management systems. And at some point, it came across this beautiful island over there. So we took a look at it and decided, like, hey, what is this? We need to investigate it. So, and in order to investigate it, we sent out a little dude. And what he found was amazing. And when he investigated it some more, it was so amazing that he said, like, hey, let's just ARrrrg, right? So if you didn't get it, this is ARrrrg, Augmented Reality. Pirates say R a lot, so that's why I thought for an augmented reality talk, Pirates theme perfectly works, right? Okay, it's all a bit enforced, and it's all a bit really hammering this thing, but yeah, I'm just gonna go with it. If you don't like it, I'm sorry. So what is ARCore, and what is the demo there? Obviously, ARCore is from Google. It got announced, I think, last year at some point, and it helps you taking a look at the augmented reality. They also released a demo for it, and this demo takes care of mixing the CV sensors on your phone. And what it does with those sensors is it's showing you an image. Okay, it takes your camera, shows the image of the camera, but the beautiful thing is you can now also add objects to it. So you can augment the reality. Arrrrg. By the way, I keep doing this one. At some point, my voice will go down, so if this happens, Sava will just take over the talk, right? Yes, okay, good. So let's take a look at the images, right? So together with the library, they also created a demo. And this demo is part of the GitHub repository, so you can check it out, install it, and take a look what it does. So what we see here is a nice image of the bar we have in our at my workplace, and there you see the pattern down on the floor, which is not actually there in reality. So this pattern is just generated from ARCore demo, and how does it generate this pattern, and what is it? I highlighted this part over there in the corner, and it shows us some points. So those points are feature points ARCore detects, and then actually takes a look at those points and see, okay, which points of them fit together to actually make a plane, a horizontal plane in space. This is one of the features. What it also can do, if they really found stable feature points, then you can also place an object not just on the found plane, but also close to one of the feature points. So you have the horizontal area, and you have some parts of the vertical parts area. So, and as I already spoiled the surprise, what you can do when you have found a plane, you can add objects to it in the demo. So as soon as you tap the screen on your phone, which is the image we are seeing here, on this place, it will add an object there. So obviously it's about Android, so it will be a little Andy. Say hi to Andy. Thank you, guys. So you tapped it, and it put it there in space. So maybe afterwards, we can have a little demo there, and I can show you that it's really stable. So you can walk around it, and it will stay in the space in reality. The other thing you can do is okay, this looks nice, but what about if we want to put an object down there in the black area? How does this look? So this one looks darker, but if you compare it to each other, you see that also ARCore takes a look into the general lighting conditions of the scene it sees, and then just makes this thing darker. And this is a nice feature because it actually adds to the immersiveness of the app. And just if you would have it the same luminance, the same lightness, then it would probably stick out more than it does right now. So let's walk through, time for keyholing, I don't know. Yeah, let's take a look into the GitHub and find treasures, right? First, let's start with the assets. Like, how does the thing we have seen right now actually like get into existence? This is a list of the assets folder, and we see already like some known things. I will not go into the details of a PNG image because, okay, the PNG format is rather cumbersome, so I just show images instead. So those are the textures we put on the ND object. So we have this big green one over there, which is like, just imagine you fold it somehow specifically onto the object, and then you see like, okay, the little eyes and the antennas. And this object is, this texture is used as, this image, sorry, is used as the texture for the ND object. The next green thing over there is the surface of the plane we've seen in the first image I showed, which is just like, okay, I found the plane, so we have to show it somehow. And the last thing is not like the nose of a pig or something. This is actually the shadow texture. So like under the triangles, you see like some dots. And if you see the ND figure, it's like has 2 legs. And like underneath the legs, there is the shadow map. And this is just like, okay, this is part of the assets. And let's go a bit more complex. So how does the actual 3D object look like? This one, it's called like the ND object, and it uses the wavefront object file format. It kind of looks like this. So this is actually an excerpt of the real file, but it's like it has way more lines of code. But it shows like the structure of how this object wavefront file works. So we have lines starting with a V, which means like this is a 3D point in space, so it's called a vertex. And we have them under a list, so like all of the corner points of the ND object are stored with the starting V letter. Next thing is we have a VT, which is the texture coordinate, or a texture coordinate. So it just enumerates all the possible texture coordinates this object can have. So this means like on which 2D image, which 2D pixel does like an edge corner point have of the 3D object. Next thing is the vertex normal. So like this specifies like what is the normal of the 3D corner point of the 3D object, which is super important for lighting and other things. Yeah, I ignore the S1 because right now I don't know what it means. If somebody knows, shout it. If not, there is also in the links the full specification on Wiki. The last thing is now connecting all the things. Like the F statement starts all the faces. So the faces are defined by indexes into the lists I just described. So like you see like a 3, like you see that there are like 3 numbers in every value there. So like we have the 1, 1, 1, which means take the first index of the vertices, take the first index of the texture coordinates, and take the first index of the normals. So and then like the library they are using can combine it together to like one real object. And we have obviously 4 of those triplets there because it's a quad. So like those 4 things are taking 4 3D coordinates, putting them all together, put the texture coordinates on it, and this defines the whole object. So this is how it works down on the middle, right? So like this is how you would write the file by hand, but I don't think this is how like we would do it, right? So normally we would use a 3D modeling tool like Blender or 3D Max or Maya or whatever. So this is a screenshot of Blender, and this obviously also shows the object again, just shaded and in 3D space. What's here also to be seen is, again, the eyes are not part of the 3D model, but they're part of the textures just wrapped around. So yeah, this is how we define the object. So what do we have? We have the textures, we have the objects. What else do we need? We need something as an asset called a shader. And we have 2 kinds of shaders. We have a vertex shader and we have a fragment shader. So let's take a look quickly at the vertex shader. What is a vertex shader? It takes the 3D object, it takes the corner points of the 3D object and then maps it to wherever the camera is. So this is like the general idea on how this thing works. It has a lot of math in it, so if we want to go into the details, we can do it later on, but I don't think it's right now the good time. So what it does, it takes, like I said, all of the corner points, multiplies it with the translation and transformation of the object, and gives it into the fragment shader for the next step. It does the same with the normal and actually just stores the texture coordinates of this vertex. And also the position. So like the position is on the screen, where would it be where would the 3D object coordinates be on the screen? And so this is the vertex. So the vertex shader takes care of all the corner points. We also need something which takes care of the pixel, right? So this is the fragment. A fragment is a pixel in this sense and would be the next step. Once the vertex shader is done, it gives information to the pixel or the fragment shader. And now it looks even more mathy, right? So except for the vec4 object color, this is actually for me still readable. So texture 2D means, okay, I have a two-dimensional texture and I have a coordinate and I probably have a sampler, which is like an image in GLSL sense. And I just tell with texture 2D, like, hey, okay, give me the pixel color at this position from this texture. And then the fun starts. So in order to calculate the diffuse part of this pixel, like, okay, what kind of lightning, or the diffuse is actually just before the lightning comes in, if I remember it correctly. In order to calculate the impact of those sources, you have to like do dot multiplications, linear math, right? We can go through this again, but please don't ask me right now. So this is like still the easier part, and then we do some more transformations with color and the material parts you put into the shader. And in the end, you end up with like GLFrag color. GLFrag color is the result of this fragment shader. So like what you put in there will be like displayed on wherever the shader is applied to. So in this case, it just says, okay, takes the alpha value of the texture. So like we can also have transparent parts, for instance, for the shadow texture, and calculate the RGB value of the fragment color by magic of math. So again, it's, yeah, like I said several times. It essentially combines all the color lightning values together, uses the right sprinkle of mass everywhere, and then does magic to actually see how it happens. So if you would just put RGB equals vector 3100, for instance, it would mean, okay, I just want to have a red pixel there. So yeah, this is my quick intro to shaders. And I'll just continue running through. Yes, so also this actually ends up having our assets. So as Sava mentioned, don't really take a look at the map because it's inverted, right? It should be flipped. Sorry for that, but you know, pirates don't need maps, we just drive. Shiver me timbers. I don't know, it sounds piratey to me, and code is something which you write on paper, and timbers is the tree, so I think this totally work together, right? Okay, yeah, so let's just continue running through the code. So, sorry for the Kotlin lovers in here, it's Java. And since I'm doing Java a lot in my work, I was surprised to still see like something like a package info. I don't know, that feels super enterprisey to me, and it's like defining what this package will be, but I have not seen this in Android code so often before. So it's there, take a look at it, it's kind of nice. But and the other things I was more interested in is like, how does the actual rendering works? Like, how do I tell OpenGL like what shader to use, what object to use, and those kind of things. For me, I'm just taking a look at the point cloud renderer for now, which is, if you remember, renders the green points in the scene I've been showing in the first. This is all OpenGL stuff, so I'll just break it down into those things. So it uses OpenGL again, and for using OpenGL, you have to create an own thread where all of the OpenGL commands are executed. Otherwise, you would probably block the main thread, and as UI developers, we know we don't want to break the UI thread or even like just delay it. So you have to create your own thread running on OpenGL, and the point cloud renderer like creates itself, so to say, in the create method. So it ensures with the create on GL thread that it's running on the GL thread, and in there it uses GL commands for creating a vertex buffer object, which is the storage on the GPU to actually put in the 3D object information it needs. and also creates other things, like, for instance, that was like super surprising for me when I came across this the first time. Like, it takes the string of the shader code, tells the GPU driver to compile the shader, then it gets a binary, and then it can execute this shader code every time when it needs to render. So this is happening on the create_on_GL thread. But also, like, if you're moving around, that there will be changes in the point cloud, right? So there might be new feature points coming in, or old feature points are removed. So you need to update this data somehow. And that's where the second method comes into place. This is the update point cloud. So this is just taking new data sets and essentially like uploading the new data sets to the GPU. So that the third method can actually take a look into this and actually draw the point cloud on the screen. Which is, yeah, okay, it takes the matrices to actually like represent the object in 3D space and just like puts it there where it should be. So this is like the quick run through over like how a renderer works. This bird, I think this bird is just looking for his other bird friends, which you might see in a second. Yeah, I'm just delaying talking about the Hello AR activity for a bit because, yeah, I don't know. Like, what you're seeing here is one method. This is the Ondraw method. And it does beautiful things. It does things like the tab handling. It takes a look if I need to create a new object. It takes a look into if I have to disable the fragment which I showed while I was loading. And those beautiful things. So, like, assume you want to change it, right? So, let's say you want to add another object or make sure that the object rendering and stuff works the right way. You gotta do something like this, right? So, again, pirates, you're hunting for treasure inside the... those are like 107 of lines of code in one method, which makes it, for me, with like 4 loops inside and 2 for loops inside. I was surprised to see it this way. So what do we do now? What do we do? I fork, right? That's now a word. I forked the code and took a look like, okay, how would I do this? This doesn't necessarily mean it's better, and it's just taking a look what I can do with this thing and maybe adding another thing, right? So right now it's limited to only render ND. Like, sorry, don't get me wrong, nothing against ND, but maybe there is more than ND. And there is, if you want to take a look at my GitHub repository, it's pirate ARrrrg GitHub on Bitly, and there's also this beautiful QR code, which Sasa, you have to take a picture of. Thank you so much. Just waiting for some more seconds. Also, if you want to take a look at the slides, it's bit.ly pirate AR-CH. So instead of GitHub on this slide, you just write CH, which I hope is Switzerland. Okay. The best feature for me is obviously it has a nicer icon, which you in the back row can't see. It has a pirate icon on it. So immediately way more nicer. I personally, again, it's code, so it's a bit personal taste. I like the separation of code more because I have it in more than one class, and it's like separated by concerns. And as you can see here, it actually renders more than one object. So this is another screenshot of the app I did, and you can select the bird, you can select the Contentful logo for some reason, and you can select the Android icon. So if you select it and then tap on the screen, one of those objects you selected will actually appear on the screen in virtual reality. That was wrong because it's augmented reality. Virtual reality is when you use like goggles on top. That's the big difference. So yeah, like how does this look in closer to code lessons? Okay, also I wanted to just show off the icons some more because like I realized today in the morning, part of my talk is like how to take your favorite toys with you without taking your toys with you. And this is like if you use this app, you can have the bird, the Andy, the Contentful logo, all with you without needing space in your suitcase. Also again, thank you for my hand model here. I think she did a great job there. So on this slide, I have tried to visualize a bit of the changes I introduced. So like on this side, we see the AR demo, which is the code how it worked before. Essentially, a lot of things were happening inside the Hello AR activity. What I decided is, okay, let's split this and have like one scene who does like management of the objects, and then also have like renderers again who are doing just like the rendering of things. I decided to have the Hello AR activity like be the communicator and just like handle it to the scene if there's a new object coming in or something, so that it doesn't need to be taken care of in the Hello AR activity. And instead, the Hello AR activity can focus on just like UI handling. So like I do a tab, what happens then? And yeah. Exactly. So the things which I didn't mention is also the scene knows what objects it has, right? So object in this case is a renderer. Like we have a 3D, we have the object file renderer, and we have text renderers. We have a UI renderer, for instance, so that you can have an Android activity layout inside augmented reality rendered on a plane. Which I think makes it super easy, because I don't know if you ever have to handle text inside 3D rendering. It's a kind of a pain. So I really like the idea that like you just take the Android layout, render it to a texture, and then display this one on a plane. And this is like part of a new renderer I added, and the scene is just like managing all of those things. It has a list of all of those renderers and just renders them at the right turn. Okay, what else do we have? Yeah. So the magic I was talking about is like, how do you render different toys, right? So as you've seen before, the object files are inside the assets. So like it would have been fixed to the APK. So what I did is I allowed to download also the object files from like the SD card. So like if you have an object on your disk, you put it in a specific file, it will get loaded. Fun and benefit. The other thing is you can also have like now like another part of the app actually providing those things, like I don't know, downloading them from the internet or something, and you would be able to just change them easily. Yes, and so like the result of the outcome is like the Ondraw method, which was like this hunking huge thing, is still 60 lines big. Probably I can like just extract some more methods there, but for me this was enough for now. It still has like 2 for loops inside of this method, which okay, kind of works, but like always with open source software, if you want to have a PR or if you want to give me a PR, it's highly appreciated. But yeah, so, and this is already like closing this talk, but let's first summarize it. So in the end, ARrrrg, we found the treasure and extended it, and yeah, I don't know, like I wanted to think of a storyline after this one, but yeah, this was where my creativity went just flat. So just think about like that pirate guy is now happy he can do augmented reality. And he did this by using the ARCore demo from Google, which obviously like the source code like is there, and it's like from Google, so I didn't write it, I just wrote stuff on top. Then we have the Pirate AR GitHub, which is like the repository I did, which is forked from it, so you can see the differences and the additions I had there. And what I would ask you, like, if you want to do an AR app, you have like several options. You can do it in Java, probably also in Kotlin. You can do it in Unity, or you can do it in Web, or you can do it in C native, or whatever. So I would just like appreciate all of you, like encourage all of you to take a look at it and see what would you do, right? What would be your take on like I want to have something virtual in my reality. This is my summary, and because like there's this big bird icon, I have birds here. The thing with birds is they fly away, and they fly towards the best question I get. So if you have a question and I like it, then you get a bird. So I would end my talk here and ask you for questions. There. What about the virtual place? Vertical place. So ARCore does not detect vertical planes. What it detects is feature points. So you can either like tap on like planes this way, or have a super stable feature point on the wall, and then you can put objects close to there. So it's not a plane, but it's a feature point. So. And by the way, I should have said this earlier, I cannot throw, so sorry for you guys behind there. Hey. Thank you.
Now, I played around with a couple of the demos, and I play around with my kit. What I do is that I try to put an object like Andy next to the couch, and then we run around the house and try to find it.
Yeah.
Now, the strange part about it is that you can actually see Andy through the walls.
Yes.
So is there there's a limitation of the framework, or is there a limitation of the software?
So the question is like, if something is like, I don't know, in reality blocking my virtual object, why is this and where does it come from? So like, what happens is first you render the image of the reality, like coming from the camera. And then you apply on top a virtual 3D grid. The problem there is like right now, ARCore does not know about like what is clipping, like what is in reality before my virtual object. But I know that they are working on this one. But so like at some point we might get like some like just clipping so that you can actually have the couch and then behind your 3D object. Yeah. You see, I cannot throw. It's also community made. Hey. Yeah.
It's fine, but then if you close your session and you come back to it, everything is gone. So do you have any recommendation on how you can restart your application and everything is still there?
So the question was like, how do I restore a session which I had before?
You already placed your objects a bit everywhere, right? But how do you actually come back to it and it's still there?
Sehr good, sorry, very good question. That was pirate speech, not German or anything. I don't know, there is no solution for that one yet. So like there are other frameworks who do something like this. I think Wikitude might be able to do something like, okay, I have a marker and I can find the marker again, but sadly ARCore does not offer this one. So close. So I have one more. Okay, you raised your hand and I didn't see somebody else, so I have to take you, I'm sorry. Kidding. What's the first name?
What's the bird's name?
What's the bird name? Yeah. Obviously, it's called ARrrrg. ARrrrg, the AR animal. So yeah, also I'm out of birds, but if you are not out of questions, I'm happy to take them. We still have some time, right? He said yes, so. Was there something? No, I saw something moving. Over there. Yeah.
Do you have to take care of the scale of the object while it zooms away from you, so while it moves away from you?
So if I understood the question right, what happens if I move away from the virtual object? Do I have to scale it down or does the library do it? Right?
Yeah, and the speed and everything that contains on it.
Luckily, this is what the library does. Sorry, like just let me answer this question because I'm like having a hard time hearing you. But like if I put an object there and then move down, ARCore makes sure that the scaling is right and also it is there fast enough. So like also like the tracking is actually stable. So like if you move too fast, obviously it loses tracking, but if you don't move too fast, it keeps there. I'm not sure if I tackled your question the right way though.